Hello my dear students, I welcome you all in this session. Today we are going to discuss exercise 10.2 in detail. So what are the concepts needed for this chapter I have already discussed in the previous two videos. The most important thing is in this chapter you are going to use theorem number 10.1 and 10.2. So first of all, you go through that video in which I have discussed theorem number 10.1 and 10.2. What are the statements and how to prove it? These all I have done in the previous video. So my advice is, so before going to solve exercise 10.2, first of all you go through that video, you understand the concepts very well, and then after you proceed this chapter. Is it okay to everyone? So let me to start exercise 10.2. Question number 1 says, see, what the question, first read the question and after that we'll go for solution. Recall that two circles are congruent. We have already seen what is the congruency. Congruency means if two figures are exactly same in shape and also equal in size, then the two figures are known as congruent figures. Means shape is also same and size will be also exactly equal. Is it clear to all? Okay. Recall that two circles are congruent. So the two circles should be congruent. How they will be congruent? If they have the same radius, right? If they have the same radii. Prove that equal chords of congruent circles subtend equal angles at their centers. What we have to prove? If two congruent circles are there and they have the equal chords, it means what? They will subtend equal angle at the center. The question is clear to everyone. What is given? We have two congruent circles, right? So this one is a circle having radius r, and we have another circle. It is congruent means they have the same radius, right? See, so we have two circles, two congruent circles, and what is given? Equal chords of congruent circles. Suppose these two chords are equal. Suppose this one is one chord and this one is the another chord. This is the center. Suppose this is O dash and here it is O. This chord is AB and this chord is CD. Equal chords of congruent circles subtend equal angles at their centers. See, the angle subtended by the chord AB is AOB. Angle subtended by chord CD is CO'D. So what we have to prove? To prove angle AOB will be equal to angle CO'D. This we have to prove. AB is equal to CD. It is given in the question, right? So what we have to prove is angle AOB will be equal to angle CO'D. The question is clear to everyone? Okay. So coming to the solution, I hope you can do it, but let me to explain. See, here we have two triangles, right? So take the two triangles. I am taking one triangle is triangle AOB and other one is triangle CO dash D, right? What we have? AB equal to CD, this is given, right? OB equals to OD, equal radii, because these two triangles are, sorry, these two circles are congruent, so the radius will be equal. Radius of congruent circles. Similarly, you can say AO equal to OB equal to O dash D. Similarly, you can say AO equal to C O dash. The region is same, radius of congruent circles. Is it clear to everyone? So you can say these two triangles, so you can say triangle AOB and triangle CO dash D, these two triangles are what? Congruent. And what is the congruency criteria? See here, this is side, side, side. This one is first, this one is another side, and this one is the third side. So you can say side, side, side congruency criteria. Is it clear to everyone? So what we can write? Angle AOB will be equal to angle CO dash D by CPCT, corresponding part of congruent triangles. Proved. So this is the result which we need to prove. So we have proved angle AOB equals to angle CO dash D. Is it clear to everyone? So question number 1 is we have already completed, right? Question number 1 completed. So 1 is completed. I hope everyone is clear about it. See, question number 1 is clear to all of you. So coming to the question number 2, right? Question number 2. Okay. Now you come to question number 2. So question number 2 is, see what is given in the question number 2. Prove that if chords of congruent circles subtend equal angles at their centers, then the chords are equal. Means it is the converse of question number 1. Suppose we are having two circles and these two circles are congruent, right? Suppose these two circles are congruent, they are subtending equal angles at their centers. Suppose this is AB, this is center is O, this is CD, center is O dash, and what is given is angle AOB is equal to angle CO dash D. Then we have to prove that these two chords are equal, means AB will be equal to CD. This is converse of question number 1. I think you guys can do by your own. So let me to try. Okay. So in this question also we are going for congruency theorems, right? How you can do it? See, we have to take two triangles. these are the two triangles. See here, one is triangle AOB. Let me to change the color. Triangle AOB and triangle CO'D. What is given? Angle AOB is equal to angle CO'D. It is given, right? Is it clear to everyone? Anybody having any confusion? I think no one. Okay, good. OB equals to O dash D, radii of congruent circles. Similarly, you can say AO equals to CO dash. The region is radii of congruent circles. So see, this angle is equal to this angle, this side is equal to this side, and this side is also equal to this side. So these two triangles are congruent. So you can write triangle AOB is congruent to triangle CO'D. The congruency theorem is, say, side angle side. So the congruency theorem is side angle side congruency criteria, right? So we can write AB equals to CD by CPCT, which we need to prove, which is proved. Is it clear to everyone? So I hope question number 2 is also clear to everybody, right? You try by your own. If you try by 2 or 3 times, if you practice, then you can be able to solve it easily. Is it clear? So thanks for watching. The next exercise we'll do in the next video. Keep watching. Thank you.